friends, good afternoon. Hi friends, good afternoon. Today we are going to discuss another section of differential equation, that is linear differential equation, right? So last class we seen first order linear differential equation, right? So today we focus on higher order linear differential equation. So what is first order linear differential equation? Dy by dx plus p of x into y is equal to q of x, right? So here first order linear differential equation, right? So now if we consider a second order, third order, fourth order, if the order of a differential equation is, we already seen first class what is order and degree. So higher order differential equation, how we solve, that only we are focusing today, understood? So look here, general expression, suppose nth order one differential equation, then dn dx raised to n plus some constant, say a1 n minus 1, right, here y, and dx raised to n minus 1 y plus etc. is equal to some function plus, right, some say a n y equal to some q of x, right? So this is a differential equation, see. So this is the differential equation, basic form, right? Alright, now look here, this is a differential equation with the right side one function, that is q of x, right? Here nth derivative, right? So dny by dx raised to n. So nth derivative differential present in the equation, right? So this may be second order differential equation, third order differential equation. So this kind of higher order differential equation come, how we solve this? So we have different methods. So let us go to directly, see, look here, this is the method. So what is the general equation we seen? Generally we seen d raised to n y by dx raised to n plus a1 into d raised to n minus 1 dx raised to n minus 1 y plus a2 into dn minus 2 dx raised to n minus 2, right, y plus etc. equal to some q of x, right? Now this differential equation solution consists of two parts. So say the differential equation, this differential equation solving, the solution say y, that y has two parts, one is complementary function, second one is particular integral. After finding complementary function and then finding particular integral, then by adding that two, that is the solution of the differential equation. Now let us discuss what is complementary function and what is particular integral, right? So suppose this left side part, right, this part you equate to 0, then you get one solution, that is complementary function. Then we find one solution corresponding to this function, right? For finding this part solution, left hand side part equate to 0, to find one solution, that is complementary function, right? And then by considering this part to this part, by considering the right hand side part, understood, we get another solution, that is particular integral. If you add both the solutions, that is the final solution of the differential equation, alright? So how we find this side solution separately, this side solution based on the function appearing here, right hand side, we have different methods, how we find separately, right? So very simple. Now let us go to different methods. First of all, one differential equation, first method is, suppose one differential equation, suppose a second order differential equation, d square y by dx square plus 3 dy by dx, right, plus 2y equal to 0. Right, this is a differential equation. This is a second order differential equation. Alright, so first you write this is in the format. Suppose dy by dx you consider as an arbitrary constant m. So generally we write this as m square plus 3m plus 2 equal to 0. Understood? This part I am considering as 0. This part first we thinking about no function present on the right side. We equate to 0 only. Then how we find the solution? Alright. So m square plus 3m plus 2 is equal to 0. That is m plus 1 into m plus 2 equal to 0. Then m has 2 value, m is equal to minus 1, m is equal to minus 2. If both the m values are different, you have to write the solution like this. First this m value say m1, second m value m2, then c1 some constant into e raised to m1x plus c2 e raised to m2x. This is the solution, right? Now what is m1? Y is equal to c1 e raised to what is m1 minus x plus c2 e raised to what is m2, that is minus 2x. Alright. Now another case, suppose the function all are different, you can write. Suppose by solving some other equation, see, suppose a third degree equation you solve. Suppose you get a m1 is equal to 1, m2 is equal to 2, m3 is equal to 3, like that 3 values you are getting. Then what is the solution? C1, y is equal to C1. This is the solution known as complementary function, right? Then C1 e raised to m1x, that is 1x, plus C2 e raised to m2x, that is 2x, plus C3 e raised to m3x, that is e raised to 3x. This only solution, right? Alright. Now, so if m value is different, we do like that. Now, see one solution, one question given like this, right? One question given. The independent solution of the equation d square y by dx square minus 3y dy by dx plus 2y equal to 0 are, right? So this I can simply write m square minus 3m plus 2 equal to 0. This is m minus 1 into m minus 2 equal to 0. Then m is equal to 1, m is equal to 2. Then y is equal to c1 e raised to 1x plus c2 e raised to 2x. So independent solution means this is one part solution, this is another part. So two terms present in the solution. This is known as complementary function, right? Then c1 e raised to 2x, or you can take this as c2, this as c1, c1 constant, any value you can specify. Then c1 e raised to 2x, that is here, and c2 minus not coming, then both plus only coming. Here 2x and x coming, then c1 e raised to 2x, c2 e raised to x. Then you consider this constant as c2, this constant as c1, no issue. Then option this is correct. Alright, and this is not given, this is not given. Alright, alright. Now let us go to another case. Suppose now what we studied, you getting different solution as different. So by solving, say you get m1 is equal to not equal to m2. Put m1 is equal to 1, m1 is equal to 2. Like this come means, what you write? You write m1 is equal to 1, m1 is equal to 2. You can simply write y is equal to c1 e raised to 1x plus c2 e raised to 2x, right? This is the method by considering c1 e raised to m1x, c2 e raised to m2x. Now suppose you consider a differential equation like this. Say d square y by dx square plus, right, and say this is 2 dy by dx plus y equal to 0. Then what you solve? M square plus 2m plus 1 equal to 0. that is m plus 1 whole square is equal to 0. Then m is equal to minus 1, m is equal to minus 1. In this case, both m1 m2 equal. That case, this method is not possible. Right. Suppose say both m1 m2 equal, then you have to write a solution like this: c1 plus or c1 plus c2x, or you can write as c2 plus c1x, or you can write as c1x plus c2. That also you can write, but one constant plus other constant into 1x, right? So c1 plus c2x into e raised to mx. M is one of the solution. Both solutions say m1 is equal to m2 is equal to m, right? Then e raised to mx means m is minus 1 x. This is the solution. So if this is two solution of this equations is same, then only this method we apply, right? Now suppose here you look, see, suppose you go to one solution, m1 is equal to 1, m2 also 1, m3 also 1. Okay, the three solutions are equal. Then what we write? Then you have to write like this: c1 first constant keep like this, second coefficient multiply with x, third coefficient multiply with the x square. Now both these all are equal to finally m, e raised to mx. M is what? 1. m1 equal to m2 is equal to m3 is equal to say m. That is 1. Then e raised to 1x. This is the solution. If four solutions are equal, say m1 is equal to m2 is equal to m3 is equal to m4, you are getting equal to m. All values say 2. Then what you write? c1 plus c2x plus what is y value? c3x plus c4, sorry, x square plus c4 x cube into e raised to mx. That is what is m? 2. Then 2x, right? So this is the solution. So this is the method. So if first you find auxiliary equation. Auxiliary equation means equation right in the form of in terms of m. Then by solving you get a y value. If all the m are different, c1 e raised to m1x plus c2 e raised to m2x plus c3 e raised to m3x, where m1, m2, m3 all are different, right? If m value is same means you write like this. Alright. Now let us do one example, then you get more idea. Alright. See one question here. See what is the question given. See d square y by dx square minus 2 dy by dx plus y is equal to 0. What we have to write? First we write auxiliary equation. M square minus 2m plus 1 is equal to 0. This is say this is m minus 1 into m minus 1, right, equal to 0. Then m is equal to 1, 1. Then m1, m2 repeating. Then what is the complementary function? That is the complementary function is the solution. This side no function. Then particular integral we need not find. Understood? So y is equal to what we find? That is c1 plus c2 x e raised to mx. M is what? 1x, right? So this is the solution. Alright. Alright. Now let us go to another question. See what given here. See, look here. Here a second order differential equation is given. D square x by dt square plus 2 dx by dt plus x is equal to 0. X of t is equal to 1. This is not x of t. Here x of 0. Right. X of 0. Right. Like that only condition will give. Right. Now what is, look here. First we can write this auxiliary equation. M square plus 2m plus 1 is equal to 0. Alright. Here not dy by dt square. Here variable is x. That you think. Variable is x as a function of t only. Understood? With respect to t only differentiating. Alright. Now look here. Here what is this? M plus 1 into M plus 1 equal to 0. Alright. Then M is equal to minus 1 minus 1. Then what is our solution? By solving auxiliary equation, we getting two M values same. Then C1 plus C2x e raised to M1x, that is minus 1x. Now here, here we have a difference. We unable to write a solution like this. Why? Why? Because here variable is x. So solution getting is x only. Then x of t is equal to, x is a function of t only, variable is with respect to t only, equal to C1 plus C2t into e raised to minus t. Alright. Now they given one condition. Alright. To solve C1 and C2, they given one condition. Right. What is the condition? Condition is x of 0 is equal to 1. Put x of 0, t put 0. Then x of 0 equal to C1 plus C2 0 plus e raised to 0. X of 0 1. Then C1 is equal to 1. After getting C1, C1 value we already getting here. Now differentiate this. What is x dash of t? Right, x dash of t. What is x dash of t? Differentiate. C1, right, C1 on doing 0, C2 into t on doing 1, right. So we can use product rule. So am I right? First function into C1 plus C2t into e raised to minus t on differentiating minus e raised to minus t plus now e raised to minus t into differentiating second function. Say first function I taken this and second function done. Now second function I am keeping and doing first means this is 0, this is 1, then here C2 only, right, C2 into 1. Now x dash of t, x dash of 0. Suppose you put a 0 here, right, tu equal to 0 either side. Then here C1, right, 0 means here C1, minus C1 will exist here. Here 0 means C2 only. Now x of, this is dx of 0 divided by dt equal to minus C1 plus C2. Now what is x of 0? X of 0 is 1. That you put here means you get d by dt of 1, that is constant, that is equal to what? 0. 0 is equal to minus C1 plus C2. Then C2 is equal to C1. So C2 is equal to C1, C1 we solved. So this all equal to 1. Now substitute the final expression here, right. What is x of t then? X of t is equal to, put 1, right, put 1 here, 1 plus C2, that also 1 plus t into e raised to minus t. This is the solution. Alright. So 1 plus t into e raised to minus t. Alright. Alright. Now let us go to another section, C. Now we see in one method, right. So if auxiliary equation finding, two possibilities we seen, different m1, m2, m3 value getting, or equal, sometime equal m1, m2 value getting. Now suppose by solving a differential equation, for example, see look here, d square y by dx square plus 4y equal to say 0. Then what is this? M square plus 4 is equal to 0. Then m square is equal to what? Minus 4. Then what is m is equal to what? Plus or minus 2i. Right. Negative root is complex number. So suppose our solution, that means m commas a plus or minus ib, or alpha plus or m come in the form alpha plus or minus I beta, then what is the particular integral? That is the next. Then if m you are getting in this form, what is your solution? Y is equal to e raised to alpha x into cos c1 cos beta x plus c2 sin beta x. This is the solution, right? So first you write this is the real part alpha, that you write as exponential function power into this I beta corresponding c1 cos beta x plus c2 sin beta x, alright. So this is the solution corresponding this. So if alpha plus or minus I beta coming as the m value, then you have to write y is equal to e raised to alpha x into c1, here not beta x, this is cos beta x, right, cos beta x plus c2 sin beta x, alright. Please remember some typing error is there. Now okay, let us do one problem, then you get more idea. See for example, one example is given here. So what is question? d cube y by dx cube equal to what? Minus 8y equal to 0, right. This is actually m cube minus 8 is equal to 0 format. Now m cube minus 8 you can write as m cube minus 2 cube into, that is equal to 0. A cube minus b cube is a minus b into a square plus ab, right, ab plus b square equal to 0, alright. Now one solution m is equal to 2. Second solution you are getting by solving this I can write as m square plus 2m plus 1 what? That is m square, this I can write as m square plus 2m plus 1 plus 3. This part is what? M plus 1 whole square plus 3 equal to 0, right. Then what is m plus 1 the whole square? M plus 1 the whole square is equal to minus 3. Then what is m plus 1? M plus 1 is equal to plus or minus 3i. Now what is m? Alright, sorry, root 3i. Understood? Take a square root, right? Negative root is complex number. Then what is m? Minus 1 plus or minus root 3i. Then what is the solution? Y is equal to complementary function is the solution. What is that? E raised to, this is alpha plus or minus beta I format. But we have to write e raised to alpha x into c1 cos beta, beta is what? Root 3 x plus c2 sin root 3x. This is the solution, alright.